And what happened with all those talented people who wrote those programs is they'd already sold all the software and they basically went back to their old jobs. And there was no longer any marketing reason for them to continue to develop that software. So the perfect packages all just kind of became static, and eventually everybody upgraded their computers to the point where they couldn't use them anymore.
Hello everybody and welcome to a new episode of CAD Talk. My name is Jörg Lunch and I talk with experts in the field of computer-aided design. Today we have a guest from Canada. Obviously this is the reason why we record this episode in English. Our guest is James Johnston, Support and Training Manager with Microsurvey, a company specialized in surveying technology. Hello James.
Hi Jörg. Thanks for inviting me.
And thanks to you for being in the office so early. It's 8 o'clock in the morning at your time, and we're late in the afternoon. I think this is the episode with the largest time difference we had so far.
Good.
Yeah.
and no sacrifice for me. This is my usual start time anyway.
Okay, good. So let's start from the very beginning. Surveying. It's a very old technique, and let's say having physical measurements to do a map. That's how it all started. Probably you can give a short overview what happened since we use computers, or what happened before, and what's the big advantage of using computer technology with surveying today.
Mm-hmm. Yeah. Sure, and you're absolutely right. Surveying, or I'll try and slide over and use the academic term geomatics, is really ancient technology. You know, amateur historians will comment on how well the pyramids were built 5,000 years ago, and surveyors look at it and say, yeah, they use some fairly basic techniques that we're familiar with. And honestly, techniques that we still use. So yes, the technology's been around for a really long time. What I know that you had mentioned, because of your background, I think you said you were a physicist
Yes,
before
right.
You got into podcasting. That's another interesting question for me to ask you, but I won't. You were interested in sort of the historic origins of the math as well, and so surveyors and astronomers really specialize in the same thing, and the techniques that were developed by some very well-known figures in the astronomy world are really the basis of almost everything that surveyors do nowadays. What surveyors do is, in general, they'll use surveying sensors and they'll take observations. The observations are taken on the face of the curved Earth, and surveyors are the people who really pay attention to the fact that we're working on the curved surface of the Earth and not on a plane. There are lots of specialties that use surveying sensors, but surveyors study geomatics, and that's where what we do is we take observations, and rather than pretend that we're working on a flat plane, which you can get away with on a smaller scale, we use astronomical developed techniques to correct for the fact that we're working on the curved Earth. And that's an important part of what makes our CAD-based products valuable, because we allow for geomatic specialists to compensate for the curvature of the Earth and come up with something that other engineering specialties can work with. Now, you were interested, and the deep historical roots is something that really interests me, because I've got a bit of a fine arts background as well, so I've enjoyed studying history. Another really important aspect of what both astronomers and geomaticians do is we pay attention to the fact that every measurement is not perfect. In fact, we know for a fact there's the term normal error. It is normal for there to be error in every observation, and you need to live with that. And so both astronomers and geometicians have developed statistical techniques as well to allow us to account for the fact that there's a small amount of error, to allow us to, really predict how accurate we're going to be, or more importantly, how precise we're going to be, and to also take advantage of the fact that if you measure multiple times in redundant ways, that you can come up with better solutions. You can have more precision in your final results. So I guess that's just the other aspect that's important with astronomy, because the original astronomers, took very rough measurements. They would use a handheld astrolabe and observe a star or something like that to determine where they are on the Earth. And they knew that would be a rough measurement. And then, but they found that if they take many rough measurements, then they can start to come up with remarkably precise results.
Today, we're talking much about, let's say, it's hardware involved, like the measurement device. It's optical in all cases. I think it's optical measurement. And on the other side, you have, let's say, data processing. And you process your data and have software involved. And I think precision can be reached from both sides.
Oh, yes. Yeah. Yeah, and different types of precision. You mentioned technology. At some point in this talk, I was going to talk about the main classes of surveying sensors, and you're absolutely right. The one optical surveying sensor that almost everybody's seen on the side of the road is, we'll call it a total station, or traditionally it's called a theodolite, and it is essentially a telescope attached to some equipment that allows you to measure angles and distances. That's called the total station. That's the most important surveying sensor. At a current evolution of that now is what's called a scanner. And those are devices that we're hearing about more and more. You often see them in construction sites. And scanners are essentially like a total station, where instead of you going and measuring individual discrete points and then taking that back with you to inform things, a scanner is a device where you put it in the middle of a room, you press a button, and you say, measure absolutely everything you can see. And it just fills up a hard drive with gigabytes of data. And then the idea is, and nowadays we're calling that reality capture, because what you do once you've done that quick measurement is you take it back to the office and you start extracting, again, those discrete points from the scanning data. Another surveying sensor that's very commonly used now, that everybody has in their pocket, of course, is GPS, or GNSS, positions measured from satellite vehicles. And surveyors / geometicians have techniques that they use in order to take that plus or minus 10 feet position down to the point where we've got centimeter accuracy. What we essentially do is just link to another known static point, and then that allows you to correct as you're working. Those are sort of the three main classes of surveying sensors. Now, where was I going with this? and so you were talking about
software, I assume.
Yeah, so you were talking about the optical data and then the data processing, and you're absolutely right. The data processing is actually why we're here, because Microsurvey is a company that since the 80s has developed software packages that allow surveyors to take surveying sensing data and then turn that into a map. Then also, with what they've done with mapping of the existing world, then they can do computations for things that are going to be constructed working into the future. And as a final step, what we do is take those computations, send them back to a surveying sensor where technicians can go out and they can start to make marks on the ground that guide other engineering professions. That's an important aspect of data processing that our people do, and a very high level view of it, I guess. But the next sort of topic that we had in our outline was you were kind of interested in how our industry evolved into computers.
Yes, and overall, we're in the CAD Talk, so how it's linked to
Sure.
computer-aided design software. That's the main link.
Yeah.
Today.
Good. Yep. And that's something that interests me and interested me since I started in this industry. In the mid 80s, it had become clear that, the hand computations that surveyors had done for hundreds of years, now they don't need to do that. And now we've got relatively affordable desktop computers that we can put on the desktop in almost every surveying office. And we can start to use software to speed up all those tedious calculations that surveyors used to do. And so in the mid 80s, it's kind of an interesting thing I've observed, because I get to travel around and talk to people all over the world. And what was happening at about that time is pretty well all the technical schools that were in the geomatics industry. There was a professor or a very talented student or something who'd kind of learned about the computational needs of pretty well every surveyor within their region, and they all wrote a program that had, maybe about 100 features that were exactly what the surveyors in their region needed. And they sold it to everybody in their region, and everybody was happy. There was this period of about 5 years, 1990 to 1995, when everybody was really happy because they had exactly the package they wanted. And what happened with all those talented people who wrote those programs is they'd already sold all the software and they basically went back to their old jobs, and there was no longer any marketing reason for them to continue to develop that software. So the perfect packages all just kind of became static, and eventually, everybody upgraded their computers to the point where they couldn't use them anymore. There are a small handful of companies that had exactly those beginnings, and that's exactly what our beginnings were. Our founder, Darcy Detler, was an electronics or an electrical engineer, and he had made some friends in school with some surveyors, and they told him about the problems, and he said, "Oh, sure, I could write some programs for you that'll help." And that product kind of took hold in the province of Ontario in Canada, and also sort of gained some interest in some Alberta surveyors, and it became, the special product for Canada. But at the end of that 5-year period, our founder, Darcy Detler, decided no, he didn't want to let it drop. He wanted to make money. He wanted this to be his retirement project. So his aim from that point on was marketing. He stayed focused on marketing. He stayed focused on talking to customers and seeing if he can reach people outside of his core region. And then, so the company grew, whereas those other regional solutions, they eventually went away. And that kind of evolved into us becoming not just a computations program, but also a CAD linked program, and eventually a CAD integrated program. And at the same time, lots of energy went into marketing and expanding into those regions where they can no longer use their favorite solutions, and trying to evolve a product that was all things to all people, although never is perfect. To this day, I still talk to people my age and older who say, "I remember that old product. It did exactly what I needed, and you guys are mostly there, but I wish you were perfect."
When talking about software development, it always comes to the point where you need something like compatibility data formats, common data formats, talking to each other. When you have a surveyor in, where was it, in Ontario, and another one in, let's say, in Germany, and they want to exchange data, work with the same program, they need a common data format. That's quite an important task of software development, right?
Yep, for sure. And a huge challenge also, because data formats always, to the amateur, and I'm definitely an amateur in terms of development, but to the amateur's eyes, we think, oh yeah, we should just do that. And it turns out, no, that's the devil is always in the details. Every software program will say, yeah, I'm compatible with that format, but it's always like the 5 blind men in a room with an elephant. Their concept of compatibility with that format is quite different from the others.
Let's talk about your product a little bit. We just met each other because I've seen your, I think it's called micro survey for BricsCAD, right? And that's one of the points we want to talk about today. That it's
Mhm.
a lot of specialized software packages are integrated as an add-on to CAD software.
Mhm.
How does it work, and what is the requirements from both sides, let's say from the user side and from the like you software developer side?
Right. Yeah. We so survey tools for BricsCAD is the product that we're breathlessly away from fully releasing. And what it is it's an evolution of some existing quite mature products we have. We have two products that we've worked with forever. One's just called Microsurvey CAD, and it's an integration of the IntelliCAD CAD engine and survey tool, survey tools, we'll call it. At the same time, we've had a product called either InCAD or Embedded CAD, which does the same thing, except instead of integrating with IntelliCAD, it integrates with AutoCAD. Survey Tools, the product that we're really excited about releasing, integrates with BricsCAD, so it'll do a lot of the same things that those much more mature products do in terms of interacting with surveying sensors, in terms of providing the computations tools that geometricians, engineers, and construction people need. But in this case, it also harnesses the BricsCAD CAD engine, which I'm really quite excited about because it's such a nice CAD product to use compared to the other ones that I'm familiar with. That's the product that we're excited about releasing, and what users are going to take advantage of is the fact that they've got an add-on to a standard CAD engine that, yeah, like I said, it's a nice CAD engine to work with and an affordable one. It allows them to interact with surveying sensors. Number one, that means export data from the major classes of surveying sensors. It allows them to, a huge part of it is performing computations. So that's developing that raw data into a map. That's then designing new features. So designing boundaries, working with data to create digital terrain models, creating 3D designs, although that's a bit of a side topic for us, but it's something that BricsCAD does really well. And also preparing files from either our source or from another source for sending back to surveying sensors, and again making marks in the ground, or turning design into reality. That really sums up what you do with this plugin once you add it onto a CAD engine. And I suppose, circling back to what I said about astronomy, the thing that really differs geometricians, that is our core audience, from other engineering disciplines that also use surveying sensors, is that geometricians are always thinking about the fact that we're measuring on the curved surface of the Earth. And there's always two ways of taking optical measurements from surveying sensors. And one of them is just pretend that the Earth is flat and just use regular geometry to solve problems. Or there's the other class of computations that we always call rigorous computations, where we're actually making corrections to those plane geometry computations to account for the curved surface of the Earth. And that's an area where microsurvey really stands out. We're a little geeky in that regard, in that we want to make rigorous computations easy. And then, yeah, at the end of the day, that means you've got a fully sophisticated solution. That was a long story there. I should let you name the next topic.
Yes, you mentioned in the call we had last week that you have some quite interesting applications, the users of your software.
Mhm.
Usually, if you think about surveying, it's like, as you say, there's a side of the road, so road construction or even building construction.
Mhm.
But you're selling your software to the police, right?
That's right. Um, about the year 2000, it was discovered that police have always had to make maps of large-scale crime scenes. Um, I remember when I was a young man, I was a jurist in the mid 90s, and I was rather grumpy about being taken off of work and having to sit in a jury for a murder trial, but it drew me in very quickly. I learned a lot about how the courts work. And on one day, an RCMP officer came in as an expert witness, and he pulled out a map that he'd made of the crime scene. And I just sat straight up in my chair. Holy cow, this guy's using surveying techniques. And up until that point, I had no clue that they did that. And they would use the techniques they used back then. They would just take a measuring tape and drag it down the middle of the road and take offset measurements and use that to design a map. But at about that time as well, police were starting to discover that using surveying sensors allowed them to do exactly the same thing, but much faster. And so us and a small number of other companies discovered that market potential. And it's a good one for us because it's a market that isn't affected by the same cycles in the economy as surveying is, because we're so tied into construction. And so it's nice because it kind of smooths out the ups and downs for our business over the years. And so, yes, we discovered that most of the code that we'd already written for geometicians and for surveyors and construction people, really all you had to do was change it a little bit to turn it into a really user-friendly mapping product for the police. And that took off, and that's been, a minority part of our business, but a very steady one ever since we entered it. So we sell products that allows police to run their surveying sensor, and it makes it easy because it allows them to draw things and see a tiny version of their map on a little screen so that they know they haven't made errors. And then again, they've got a simplified variation of a CAD program that allows them to import data, create a map, and then they've got something that allows them to present to jurors.
It's always good to look into the future at the end of an interview. What will happen, let's say in 10 years, 20 years? Nowadays, the scanners, the 3D scanners they're handheld products, size a bit larger than a cell phone. You can do a lot with a cell phone as well. Will this be the future of this application, the police having a small scanner, 3D scanner, and do the surveying in a minute or so?
And honestly, it's not even the future. But yes, scanners and I'll call them reality capture products. So yes, that includes scanners. That includes things that you can capture from a handheld phone. The cost is going down very quickly. They're already fairly well established in the forensic world, especially, and they're being adopted everywhere that they can practically be used in the geomatics profession as well. You're absolutely right. That is the future. It's not going to take the place of some of those really discrete, tedious tasks, though, that geometicians need to go over. So we're always trying stuff out and finding sometimes they work, sometimes they don't. You're making a face, which I think means you can hear that drill in the next room, can't you? Darn.
I can't.
I just broke the concentration. Or would you like to edit that out and me just continue with my story?
Yes, we edit this out, no problem.
Okay, good.
So let's talk about future development at the end of our interview. Future development.
You bet.
We talked about the hardware. It's becoming cheaper and affordable, small devices. What will happen to the software? It's software as a service, obviously, and cloud services. Any special things you say this would be great in 10 to 20 years? 20 years is a long time for software development.
Well, it is, but we're such a tiny industry that it's remarkable how slow things move. I know that, and when I look at Leica Geosystems, a sister company of ours within Hexagon, they're developing products that are really good at starting to take the tedious on-the-ground tasks out of surveying. It's always been a requirement that you spend lots of time leveling your instrument in order to take precise measurements and holding your sensors up exactly correct. And Leica Geosystems is developing products that take some of that out, which is something that 30 years ago I would have thought somebody needs to develop technology to require me not to have to get my knees wet every time I bend down and put a nail in the dirt. That, as tedious as it sounds, is something that's really starting to happen right now. That's going to be an important part of the future. You're absolutely right. Reality capture or remote sensing is also going to be more and more available, definitely as it becomes more affordable. Capturing information from drones, of course, is something that's already being done, and people are exploring business models that allow them to do more of that. Combining data with readily available downloadable data is currently being done and definitely going to become the future as well. But I think that getting back to using those statistical techniques and the specialties that geometicians have in, again, taking that sensor data and modeling it on the curved surface of the Earth, I think that specialty is never going to go away. It's just not going to be replaced by a cloud server or something like that. So in that regard, I still see a strong future for the products that we offer. In terms of microsurvey, probably the most significant thing that we're offering right now is a relatively new data collection package that eventually is going to be offered in all mobile operating systems. It works in Android right now, and it really is kind of a next generation package because it allows you to take advantage of the fact that you're using an internet connected device to take measurements, and that just increases efficiency and appeals to youngsters a lot too. That's the future for microsurvey that I'm always excited about.
Okay, James, thanks a lot. That was very, very interesting. Surveying, it's a nice industry. I'm never into it, but very interesting. Thanks a lot.
It's been great to talk to you. Thanks again.
So, since the majority of our audience speaks German, we switch back to German now. Ich hoffe, dass Ihnen diese Folge gefallen hat, auch wenn sie auf Englisch war. Ein sicher spannendes Thema. Vielleicht haben Sie auch eine Anregung, welche Themen wir in Zukunft einmal behandeln sollten oder welchen Gast wir einladen könnten. Dann melden Sie sich einfach bei mir. Am einfachsten geht das per E-Mail an info@cadtalk.de. Und zum Schluss habe ich noch eine Bitte an Sie. Wenn Ihnen der CAD Talk gefällt, dann empfehlen Sie unseren Podcast gerne weiter. Bestimmt haben Sie Kollegen, Geschäftspartner oder Bekannte, die sich ebenfalls für das Thema CAD interessieren. Für heute sage ich Tschüss und auf Wiederhören.